Hello, YouTube. This is UMozo3. Now we're on lesson 17, I believe, if I'm not incorrect. And in the previous lesson, we learned about exceptions. Okay, so we had a little bit of time. We had about 8 to 10 minutes, I think, to review modules, but then we wanted to start talking about a new topic. So this is called exceptions. Okay, so basically what exceptions are is it's basically when the flow of our program is interrupted because there's some type of error. There's something that we're doing in our program that we're not really allowed to do. So these are really fundamental rules that happen in Python. And a lot of these things are true for Java as well. Like if you were talking about Java, you have arrays, you have lists in Java too. And so you couldn't access index position 4 of a list or array that only has 4 elements in it. But these are the types of errors, and these are the things that we said that could go wrong. So if you divide by 0, maybe you import a module that doesn't exist. Maybe you try to index an index position that isn't valid. Maybe you have a name error, so we said print of cats and dogs, but it didn't know what cats and dogs was. We hadn't initialized it yet. Syntax error, that we just said we tried making a for loop, but we had forgotten the colon on the end. Type error, right? So type error and then a value error. So these are the types of exceptions, and we tried basically coming up with examples of that. So where we left off in the last video is we said that we can actually raise exceptions. So we can actually pretend like our program is going to suffer one of these errors, and we can actually tell Python to stop the flow of the program. And in order to do that, we have to raise an exception. So you would want to raise one of these types of errors, okay? So you could basically raise zero division error. And then one of the things we did, so let's go ahead and run that just to review from what we said at the end of the last video. And it says raise zero division error. And we said, why do we still get a 5? Because any code that happened before the error was thrown is valid, right? But any error after this, any code after this error, you can see that this is sort of being shaded in yellow. It's sort of giving us a warning that says, hey, I'm not really going to be able to print this 4. So I would recommend that you don't have me trying to do that after program execution is going to stop, because that's what happens as a result of zero division error. But then we said that we could feed it a parameter. So we could say, you suck, or something like that. Let's keep it a little bit cleaner. So cannot divide by 0 or something like that. So now if you go ahead and run it, now it doesn't just say zero division error, it says cannot divide by 0. Okay, and you could try a different type of error. You could try an index error. Okay, and then basically you'd want to have a sort of different string here. Maybe you could say cannot index at that position or something like that. So now if you go ahead and run this code, it says index error cannot index at that position. What if you say value error, and then let's do a concatenation. So that you could say incorrect concatenated with value, right? This is just another practice of how you can add 2 strings, and that has the effect of combining their characters. So now if you run the executable file, it says value error and then incorrect value, because incorrect value is the concatenation of the string incorrect with the string value. So hopefully that makes sense to you. So it's great to raise exceptions and stuff, but what the goal would be to do is to be able to catch an exception. So it is fun to throw exceptions, but the practical goal is to figure out scenarios when our code is prone to committing an error of one of these types. We are then able to catch the exception and divert the program to run alternative code. Okay, so here's what I mean by that. What we're going to do is we're going to think about a try, except, finally architecture. Okay, so here's how this is going to work. We're going to have a try block. Okay, so this program will try to run the try code. Okay, if there are no errors in the try code, then it functions as normal code. Okay, if there is a particular exception that the try code would run, but it is successfully called out and caught with an except, then the except block will take over after the failure in the try block. So that must be pretty confusing, and I know conceptually that's a lot to take in. Here's what we're going to try doing. We're going to say try. So this is another keyword in Python. That's why it's showing up in orange. And then we're going to say print of 4 times 2. Okay. And then what we would do is we would say catch zero division error. Okay. And then what you would do is you would say print of 4 times 3. Okay. So you don't say catch, you say except. Okay. I'm thinking in Java, there's very similar architecture, but you use the words try and catch. Okay, in Python, it's try and accept. Okay, so what you need to do is what this code is going to do. So here, the try code will try to run. Okay, if it is successful, the accept block is skipped. Okay, so basically, if an error would be thrown in the try block, the accept block takes over at that point. Okay, so that's basically what's going on here. So what it does is it looks in the try statement and it says, if you get to a zero division error in the try statement. So if at some point in the try statement you divide by 0, I want you to not try to do that because that would disrupt the program. Instead, go ahead over to this alternate line of code that I'm going to instruct you to write under the condition that your try block threw a zero division error. So let me show you what I mean by that. If we run this Python executable, we're still getting a value error. So let's remove this value error that we raised earlier on. I don't know what's going on with my selecting. There's something weird going on with that. But anyway, what we're going to do is we're going to come down here. So there would be no zero division error if you just printed 4 times 2. So this code runs successfully. So this runs successfully. Does not divide by 0. So does not call an exception, or does not need to catch an exception and divert execution of the program. But here, what we're going to do is we're going to try another example now. So now what we're going to do is we're going to say try print of 106 over 0, and then we're going to say except zero division error, and then we're going to say print of I think you were about to divide by 0, ... Okay, so now what we're going to do is the try code, so that the try code only runs until a zero division error is reached. If it is, we run the accept block, at that point. Okay, so if you had had a successful line of code before that, what if you had said 106 over 1 and then 106 over 0, right? One of these lines is going to print 106.0 because we said that a number divided by a number is a float in Python. But then 106 divided by 0 would give a zero division error. So now we're going to go ahead and run this code, and for this try block we get the 8. But for this other one, what happened? So it ran as much of the try block as it could. So it ran the 106.0. But then instead of getting that annoying runtime error where it said you're not allowed to divide by 0, we successfully caught it. So we said, if there's any point in the execution of the try code where you would have a zero division error, I want you to not do that. I want you to just go ahead and print, I think you're about to divide by 0 instead. And that's exactly what we see here. Okay, so that is basically that's basically a simple example of how we can catch an exception and basically divert the flow of the program to do something else. So hopefully that makes sense to you. And we want to talk about different examples. So what if you wanted to talk about indexing? What if you wanted to talk about an indexing error? So let's do something similar. What we're going to do is something similar here. I don't know why my selecting is being like that. It's pretty annoying. But what we're going to do is we're going to say basically my list is equal to, we'll say my string is equal to basketball. Okay. And then what we're going to do is we're going to say print of my string of length of my string. So let's think about what this code would do. Remember, we said that strings, the characters within a string can be accessed by index positions, which basically makes a list a type of string. And so what we do now is we're going to basically access an index position within our string. But the index position that we're going to try to reach is the length of the string. And we said that the greatest valid index position for a string is 1 less than the length. So this would actually create, it would create an indexing error. Okay, so this would be an out of range error. This is not a valid index position that the function could return. Okay, so hopefully that makes sense to you, right? And maybe we're missing a parentheses or something here. So what does it say for that? Well, I don't know exactly what the issue is there, but now what we're going to do is we're going to say except, and then you would say index error. Okay, so you want to be able to call out the index error, and then you could say something like, you could say my string. You could say my string of 0. What happens if you try doing this? Okay, so here's what's going to happen. So we're going to run main.py, and so what it's going to do is it runs as much of this code as it can. So basically, my string has been defined because the try code ran as much as it could, right? So this line runs successfully, right? But this line does not run successfully. So this line diverts the code to accept. Okay, so then you're going to go ahead and print the accept code instead. Okay, so hopefully that makes sense to you with what's going on with that. So that's an example of how we could catch an indexing error. What if we caught the wrong type of error? So what if instead of catching an indexing error, what if we just caught a type error? Okay, so basically we are trying to catch an exception, but we're catching the wrong type of exception. Okay, so now what we're going to go ahead and do is run this, and then what do we get here? So what basically prints? So it prints an indexing error. It says, oh, you're not allowed to index at that particular position because we didn't call out the right type of error. Okay, so what we would do is you could say, you know, here you would have to say something like wrong type, but then it turns out that you can actually catch multiple types of exceptions. So now what you could do is you could say except, and then you could say index error, and then you could say indexing issue or something like that. So now if you go ahead and run the code, we are able to prevent the exception, right? So now you just get 8, and then you get index, and then you get indexing issue. So hopefully that makes sense to you. So basically there are notes to have here. So we can try to catch more than one type of exception. Okay, just state them independently. So it's sort of like an else if, right? Honestly, because these are sort of stacked on top of each other, and you know, once one of them becomes true, then it would go ahead and run it. Okay. We can also combine two types of exception into the same catch block. So this would be done if we wanted two types of errors to divert to the same type, to the same alternate code segment or something like that. So what you can do, just to remember to put parentheses around the group of exceptions. So what if you wanted the type error and the index error to report the same thing? What if you just wanted to say, oh, you know, that is wrong or something like that? So what you could do is you could actually go ahead and group these together. So you could say except of type error and index error. Okay, and so this would basically call out both of them. And then what you could do is you could say print, I think there is an issue or something like that. And then what you can do is you can go ahead and run the main.py, and then it would just say, I think there is an issue, because one of the types of exceptions, you know, in this list is the one that matched the type of error that happened in the try code. So hopefully that makes sense to you. And that's basically what you need to know about exceptions. There's one more, there's a couple more things we can say. So how much time do we have left? We have about 7 minutes. That's plenty of time. What we can do is we can also think about an assert. So basically, assert is followed by a boolean. Okay, the code continues running if the boolean is true, and the code runs an exception if the boolean is not true. Okay, so what we're going to do is, before any of these try blocks, right, we tried doing these try blocks, and this one successfully printed 8 because there was no zero division error, right? But this one diverted the code. You know, it was able to go ahead and say my string equals basketball, right? But then it would just say, I think there is an issue. So that's why we get the I think there's an issue. But what I'm going to do is I'm going to say assert 3 is less than 100. Okay, so then what I'm going to do is I'm going to go ahead and run it, and the code still compiles, right? It still ran just fine. But now what I'm going to do is I'm going to say assert not 3 is less than 100. You can see something got shaded in yellow. So there's already something interesting that's happened here. If we go ahead and scroll over, it says this code is unreachable. The way that the assert works is it throws an error and it stops the execution of the code if the boolean after the assert is not true. So since it is not the case that 3 is not less than 100, then you would go ahead and run main.py and it would say an assertion error. Okay, so I guess that's maybe another type of error that we could have, maybe an assertion error. Okay, so basically, you know, if we write assert boolean, okay, the code will continue running if and only if the boolean is true. Okay, so now you can see a type of assertion error there. Okay, so then what you could do is that's basically what you have going on there. So that would throw an assertion error exception. What if you wanted to catch a type of assertion error exception? So you could put all of this stuff into the context of a try and except. So what you could do is you could say try assert false. Okay, and so what would this code do? So if this line of code were to be run, it would, you know, throw an error, right? The program would mess up, right? But what you can do, so I just want to demonstrate to you that the beginning of the try block will run. So I'm just going to say print of 2 there. Okay, but then what I'm going to do is I'm going to say except assertion error. Okay, and I'm going to go ahead and call that out, and then I could say basically print of 3. So what's going to happen? It's going to print 2, and then it's going to print 3, and there's no assertion error. So hopefully you can understand what's going on with that. Okay. We can also think about one more thing. So one more thing I wanted to talk about is finally. Okay. So we can add a finally block after the try except sections. Okay. Finally code runs regardless of whether or not an exception was successfully caught. Okay. So if the try code runs successfully, the finally code will run afterwards. Okay. If the try code exhibits an exception, it will run until the time it is unsuccessful. Then the except block will run. Then the finally block will run. So the finally block will always run regardless. So it's like finally, like at the end of the day, regardless of how messed up this program got, I'm going to want you to do something. Okay, so what you would do is you would say finally, and then you could say print of 4. So regardless of whether or not we successfully catch this exception, regardless of how the try except block runs, I guarantee you, I absolutely guarantee you that 4 will be printed onto the console. So regardless of how the try except block goes, there is a 100% chance that the finally code will execute. Okay, so we will go ahead and print 4 here, regardless of whether or not there had been an issue, right? So this prints 2, and then it catches the assertion error, so it prints 3, and then it runs the finally code, so it prints 4. What if we had asserted true here? Then what happens? Well, now it's just going to go ahead and print 2 and then 4, because there was, you know, there was no exception to catch, but we said that we're going to do the finally block regardless. What if you had not called out the right type of exception? So what if you had said value error? So here's the problem, right? Because we said that what if we throw the wrong or catch the wrong type of exception? So here, what if we had said, what if we say false here, right? And then this exception is not going to, basically, it's not going to allow the code to divert to the print of 3. Okay, it's going to run assert false, not print of 3, because we're calling out the wrong type of error. So it would say print of 2, it will go ahead and run print of 2, and then we would have an issue, but you can try to make a prediction about whether or not we're going to make it to print 4. And so you can see that indeed we still print 2 and 4. Okay, this is always going to run. It's always going to run. But the 2 might not. Okay, so if you just assert false right off the bat, what if you had said print of 2 after the assert false? Well, now it you know, highlights that code again. It says I'm never ever going to be able to print that 2, because we're stopping the run, you know, we're stopping the runtime before you can even make it there. So now if you go ahead and print the code, you know, the 8, and I think there's an issue that's from a previous example, but for this example, you know, with the finally stuff, we still get the, you know, we still get the 4. The last thing I'll do is that you can have a string after a comma after the assert boolean, and that would print an error message if the assert boolean is false. So let me show you what I mean by that. What I'm going to do is I'm going to say assert 5 is equal to 10. 5 is not equal to 10, sorry. So basically what this happens is, and then you could say something like print of 5 times 5. So if 5 is equal to 10, then the code will keep running and it'll print 5 times 5. If 5 is not equal to 10, then we'll stop program execution and we'll get this error message instead. So now let's go ahead and run the code, and there's an assertion error, right? So there's an assertion error here. Actually, that might be from previously. So let's go ahead and delete that. Okay. And this comment thing is being annoying on me, but I just want to show you this real quick. So now if we run main.py, it says assertion error, and then we go ahead and get that error message. So not only is there an assertion error because this boolean was false, but we also print this error message. So hopefully you had a good time seeing some more exceptions and figuring out how to handle them. It's really kind of fun to play around with this stuff, so go ahead and do that on your own time. From you, Milso3, thanks for watching, and please subscribe.